A square have a side of length x and area a. So the area increase at a rate of this one. So this is the dA dt equal to 0.2. Okay, so now the question want to find the dx dt when the area equal to 16. So we have a square here. So square, the side length is x. So the area is actually x times x, that is the x squared. Okay, so when we have the a equal to 16, then 16 equal to x squared, then the x will be the square root of 16, that is 4. Okay, so so this one is equivalent to dx dt when the x equal to 4. Okay, so the a is x squared, so we have the dA dx is 2x. Okay, so the dA dx when x equal to 4 is 2 times 4, that is 8. So now we want to find the dx dt. So dx dt is equal to dx dt. Then we have the dA here. So the dA dx is 8. dx dA will be 1 over 8. And the dA, this one is 0.2. Okay, so we have 1 over 40 here. 1 over 40. 0.2 divided by 8 is 1 over 40. Yes, 1 over 40 and then cm per second. Okay, write the answer as a decimal so we can change it to this. So this is 0.025. So this is 0.025 cm per second. So we look at example question number 9. So we have a cube. So cube, okay, so this is cube. Okay, so to draw a cube, we draw a square, two square here, and then we connect. Then this will become a cube. Okay, so the cube, the side length is x. So the volume will be x times x times x, that is the x cube. So when we have the volume equal to 512, then 512 equal to x cube, then x will be cube root of 512. Then it will be 8. Okay. So the volume increase at a rate. So this is the dV dt is 2. They want us to find the rate of increase of x. Okay, so the question want to find the dx dt when the volume is 512. That is the dx dt when the x equal to 8. So we have the dv dx. So v is x power 3. So the dv dx is 3x squared. So the dv dx when x equal to 8, that is 3 times 8 squared. So we have the 3 times 8 squared, that is 192. So this is 192. So the dx dt is the dx dt. Then we have the dv here. So the dv dt is 1, dv dx is 192. dx dv is 1 over 192. Then the dv dt is 2. So we have the 1 over 86. Okay, cm per second. So 1 over 96, not 86, 96. 1 over 96 cm per second. Okay. So a sphere have a radius of r and the volume of this. So sphere, we have a sphere here. Okay. So this is a sphere. Okay. So to solve the problem for differentiation, sometimes we need a strong basis. Okay. So in the algebra and the mathematics, so the volume of sphere is actually 4 over 3 pi r cubed. If you don't know this, then you cannot solve this question. So we have the dVdr will be 4 pi r squared. Okay, so the radius increase at the rate of this one. So this is the dr dt. Okay, radius increase of this is 1 over pi. So they want us to find the rate of this. So the v is 972 pi. So we have the 972 pi is 4 over 3 pi r cubed. Send the pi and pi here, we can cancel. So the r cube is 972 times 3 over 4. So we have the 972 times 3 over 4. It is 729. 729. So the r will be cube root of 729. That is 9. Okay. So they want to find the dv dt. That is the dv dt, then dr here. So the dvdr, so the dvdr when 4 pi, this is the 4 pi r square multiplied with 1 over pi. Okay, so the pi here we can cancel. It will be 4/9 square. Okay, so we have the 4 times 9 square, that is 324. So this is 324 cm cube per second. Okay.